Good morning, everyone, and thank you for joining the webinar around virtual desktops and how the technology is evolving through various different means. Today, Simon Isherwood will be talking from NVidia, and Jonathan will be talking from Lenovo around how the hardware and the software elements come together. And ultimately, I'll finish off with how things go. So from there, I'll sign you over to Simon, who will run through the NVidia side. Just quickly, if anyone has a question, please feel free to pop it in the chat, and we'll try and answer the questions at certain points. So Simon, I assume you're ready. I will just hand you over for you to share your screen.
Okay, thank you. Okay, can everybody see my screen?
Yes, that's fine.
Right, so yeah, good morning, everybody. So my name's Simon Isherwood. I work for NVidia within what we call our professional visualization area. What I want to talk about today is VDI in general and the power of accelerated VDI from our perspective, and how this can help us address the challenges of delivering some environments within the higher education sector. So we see generally, even outside of education, the enterprise continues to evolve. People continue to change the way they work. Now more than ever, there's a greater need for mobility and flexibility. Employees are expected to be able to work from anywhere, to work on any device, and companies need to be able to bring those new employees up to speed quickly and allow them to access their environments quickly. They want users to be as productive as quickly as they can, and obviously to keep information secure in a central resource in an area where it can be best administered. Now, this doesn't differ at all when we look to the education sector. Again, the ability to remote access and remote learn is very high on the agenda, and the ability to quickly allow those users, those students, to access information areas is equally as important. So whatever we can do to provision that is exactly the same as it would be in the enterprise environment. And this is where as the enterprise changes and people change the way they work, this is where NVIDIA's virtual GPU technology absolutely comes into play. We allow IT to deliver graphics. We allow IT, to deliver graphics-rich virtual experiences across the office and across the knowledge workers and across the student campus, irrespective of whether they are productivity type application environments or whether they're creative design and technical type application environments. So the NVIDIA virtual GPU solves the problem by bringing graphics acceleration within the data center. So we've taken it away from that desktop device and delivering it into the data center itself. This enables IT to virtualize literally any platform, Windows 10 to any graphically intensive engineering applications, any scientific applications, research environments, data science requirements, and deliver those through a virtual desk or a virtual lab. That allows the students across any sort of faculty body to work from anywhere, any device. It could be another campus, it could be working from home. The fact that we've got GPU acceleration means the user experience is exactly as they would expect it to be if they're sat on a physical desktop or a physical workstation. So that virtualization can be, as I say, within a library kiosk across the campus, or within some of the most demanding labs that are being provisioned within the environment. So we see several new trends emerging within the education industry. Students entering colleges and universities are increasingly tech savvy, very tech aware, and they usually have a growing number of mobile devices, probably several at once about them. They have expectations that they want to access the same caliber of tools and graphics intensive environments as they might do in any point in their day-to-day lives. So that anywhere, anytime access to applications now becomes an absolute requirement, not a nice to have. Educational institutions are clearly wanting to offer new ways of learning. The learning environments that we have today generally are highly interactive, very personalized. Lecturers and professors are commonly using very rich multimedia and video to complement traditional approaches and enhance those learning processes. And as right up to date, we've got real-time virtual labs now to supplement classroom learning. It's really becoming more and more common and really changing the way that we see what a classroom might commonly be. It absolutely increases student engagement and retention. And if I have time later, I'll try and run a short video clip. I'm not sure how well it'll come across on here, but we'll see what we can do with that. And then finally, colleges, universities are looking for that online learning and distance learning programs as a means to expand and develop the accessibility of education. It may well be that the campuses can only get as big as they can get now. That sort of they could be even in normal times. We can't accommodate any more students, but by providing those distance learning environments and remote learning, it means that we can extend the number of students we're able to service across the campus, and obviously change the way learning is delivered. So we need to look about application and desktop virtualization solutions that we know they've been around for quite some time. But a common point of failure in the past has been down to user experience. The reason for this is that when applications and desktops were first virtualized, GPUs were really not part of the mix. Ultimately, this means that all the capture and code and rendering that was traditionally done on a physical GPU within that physical workstation or PC was ultimately being handled by the CPU on the VDI host. On the virtual desktop host. At some levels, this would be functional, but really only for the more basic applications. When you move to the levels of performance that are needed within some of these design apps that you see over on this side here, you need the power of a GPU, or in this instance, the power of a virtual GPU. So as we've got from that point that every device has a GPU, we clearly need to see the view that virtual machines also need that same GPU. In this instance, it's a virtual GPU, and providing one there delivers a very increased performance for existing VDI platforms, but clearly opens up a whole new set of use cases that would benefit from the technology. And I will go into those use cases in a moment or two. So how virtual GPU technology works, and some people on the webinar may already be aware of this, so I'll briefly go across. So the image on the left-hand side shows a traditional virtualized environment, powered purely by CPU, no vGPU involved at all. So the virtualization layer that's installed on the server. This is known as the hypervisor, what we see here. The application and VMs are accessed running on that virtual host. So any user working on their virtual desktops, the graphics commands from the applications are intercepted by a generic driver within the guest operating system. They're passed to the hypervisor to render the graphics and encode and utilize the CPU to do that. All of those tasks cause quite a significant overload on the CPU. The CPU becomes kind of overwhelmed and results in a poor user experience. So on the right-hand side, you see an NVIDIA virtual GPU enabled VDI environment. And what we see there is we've got physical GPUs in the server, and the NVIDIA GPU management software integrates within the hypervisor. And in this instance, the software combined with the hypervisor enables virtual machines to share that single GPU and provisioning a virtual GPU for every VM that's accessing the environment. So now the GPU is providing the graphics performance that it was ultimately designed for, and the user sees a much better user experience. The graphics commands and the encoding of the data are now executed on that GPU, so the CPU has got less work to do, lowers the consumption, and effectively increases the number of virtual machines that can exist on that virtual platform, and ultimately means that we can deliver those higher end applications around design and creativity, and also the media based applications that otherwise we couldn't possibly consider running. Now, even on a standard user workspace, a user environment. So when I say standard, I'm talking about those running Teams, Zoom, standard web browser, and Office productivity applications. As Windows 10 has developed over time, the applications are demanding more and more. So as we look there, even at Teams back when it first came out, the CPU usage was extremely low back in 2019. As we look today, even kind of mid last year, we were seeing a 78% increment in CPU usage. So this just utterly highlights the need for CPU offload, and we've done a number of research elements in our labs where we see the acceleration that a GPU can offer Teams and Zoom and WebEx calls alone before we even get started on the more advanced environments. This data, by the way, was provided by a third-party company, Lakeside Software. They have a tool called SysTrack, which gives digital experience monitoring. So this helps the IT departments understand what's going on endpoint, what's going on with any given platform, to enable them to improve the user experience. So it's a third-party snapshot rather than research of our own part. Excuse me. With the recent shift to remote working, we've seen a huge growth in web conferencing trends. Now, those trends have just mainly meant that the utilization spikes on the CPU has gone significantly higher. Excuse me. That's resulting in poor video quality. It's increasing the demands on the CPU utilization being off the scale. So with a GPU accelerated environment, the experience has been much better. And what I'll do here is just to show you the next couple of slides is talking about how Teams operates. When a user activates their camera, you see a spike in CPU utilization. So, and we see the points here where that's happened. When you look at the NVIDIA software and how that's offloading, so the green line we see down here is showing you how we smooth that trend out and deliver a much more effective platform. And again, we can also increase the frames per second. Just to give you that better performance. So the higher frame per second you see, the much better user experience you see. If we do it with vCPU only, the frame rate performance is not in a place where you'd want it to be. Okay, so the NVIDIA GPU portfolio is quite extensive, and we try and have GPUs, a range of GPUs optimized to run a range of different workloads and different application environments. What we're trying to do is show here recommendations around GPUs and virtual software licenses to be selected as appropriate. So we start over here. So up until a couple of weeks ago, the go-to VDI card of choice would be the NVIDIA M10, followed by the T4 for more analytical type environments and some of the more CAD related, whereas the M10 was mainly about office productivity and some of the creative Adobe applications. As we then moved further up the scale, we were into the ray tracing capability cards, the RTX 6000 and 8000. So this was helping drive some of the more intense CAD models and photoreal rendering that you might see in the media and entertainment industry and the media and entertainment courses and games development environments. And then finally, the V100 for the deep learning and data science. As of 2 or 3 weeks ago at our global technology conference, we announced our new Ampere chipset range of cards. So starting at this end, the M10 will be superseded by A16. So it's a newer generation of chipset. Likewise, a T4 will be replaced by A10 over time, and the A40 for the higher end. So the A40 is now the highest power professional visualization card available. So we can do some very intense VR and some intense photoreal and collaborative real-time working with the A40 platform. The application set you see across the bottom are typical applications that we might be considering within these environments. Okay, so within the data center, typically we might see 3 of the M10 or A16 cards being hosted on an average server from Lenovo, from Dell, from HPE, or whoever. Up until the announcement recently, we would perhaps look at 3 M10s, and that would be delivering around 96 users concurrently. As we look now, this is the power of the A16 and the difference. We can increment the user density purely because we're using less power per user. We've got better graphical throughput. We've got more RAM available, more graphical RAM available on the card itself. So you can see those, just a snapshot there of the performance differences as we go into a new generation of card. The key user groups that we see in the education space, for example, around architecture, engineering, design students, we'd make the recommendations around our virtual workstation license. It used to be known as a Quadro. We've now rebranded that as a virtual workstation. And that would be, we'd expect to be running that on RTX 6 and 8000 on A40, and to a lesser extent on T4 as well. So that's the creative design students. The general purpose VDI, again, VPC is another of our licenses, but within education, you commonly see the virtual workstation because we do apply a significant amount of discount, which makes them a similar price anyway. But that's for modern productivity environments, streaming video, multimedia, and operating the interactive learning. And then another workload is around research, and this is where we also have something called the virtual compute server. This allows us to virtualize compute for deep learning, for data science analytics, and we would commonly see that for double precision cards like the V100 or on T4 and RTX 6 and 8000. Those latter cards are what we call dual purpose. So we operate sometimes VDI by day and compute by night, which further enhances the use of an environment that might have been invested in. So the kind of environments where we accelerate productivity, I alluded to it earlier, for the knowledge worker and giving scalability to deliver as much as we can with a better user experience around these types of application use environments, all the way through to those creative and technical professionals, running some very, very high-end geo applications or rendering type applications. The kind of apps that you'll see in media and entertainment. We're doing an awful lot of work now on virtual stage, applications like GIS for oil and gas industry. All of these, we're working within universities across the UK and Europe, and well, quite clearly, but I tend to focus on UK and Northern Europe, where we see these environments run by students and being delivering the capability. The compute type that we see now, we're moving from client computing over to server workloads for all of those creative environments. And again, this is just reiterating the type of card environment you might see. So virtual data center workstations and virtual compute server. We're delivering on that within both the creative field and the AI and data science fields. So those mixed workloads I referred to, so that's VDI by day, compute by night. This may well be that during the day the platform is there to deliver some high-end 3D applications or even 2D CAD drawing or merely that knowledge worker platform. As those students log off and during the evening, we've created some batch loads that we need to then run some deep learning elements on that, because we combine that AI componentry with visualization. Then those compute models can run throughout the night to give us those results that we'd want to visualize again on a VDI platform the next day. And that could be airflow over a product design. It could be a new CPU. It could be a design of a vehicle. But that's where the compute workloads come in, and we would operate those during the small hours. The ray tracing technology, what we're seeing there is the difference, that photoreal difference that we see from ray tracing and from a CPU only render to an initial GPU render, and then optimized denoising. That's when we start to move towards the photorealistic. I hope that the imagery is coming across on the slide deck there. Okay, so I referenced the fact that sorry, I think that's my slide deck's gone backwards there. My apologies. Reference the benefits of virtual GPU and overcoming those traditional challenges. We need to deliver on that enhanced mobility and flexibility, giving the students access to all of their environments, whether it's a Windows 10 Office productivity environment, or whether it's a Windows 10 AutoCAD or SolidWorks or MATLAB type environment. We need to be able to support those interactive learning, making sure that the offload technology goes away from the CPU and onto the GPU to give a more impressive multimedia interaction, and to increase manageability and scalability, so that we can introduce the capability of virtualizing compute as well as a VDI platform, just to make sure that we can deliver on all of the demands any given university and learning environment might require. Our virtual GPUs effectively give educational institutions that ability to provide the students with the resources they need and drive moving forward. What I've got on the next couple of slides is just some examples. Simulation engineers can tap into the power of the RTX components to run advanced simulations, and this can be done virtually, absolutely virtually. An example here is Altair, where you can use fluid dynamics and airflow in design to give you accurate understanding of how those designs impact functionality. That can be fed into design decision environments, such as seen within ANSYS. So larger designs could be crafted and to respond to different fluid and air dynamics. Industry are using this type of thing extensively. Powering the digital manufacturing environment is something that a number of universities are now looking hard towards. So this is a synopsis of University of Maryland. School of Engineering, and they wanted to allow their students to be able to design, create, and analyze and iterate on ideas. Their environment now delivers their CAD, their computer aided design, their computer manufacturing, all delivered using NVIDIA GPU technology. So their students are not only on campus, they're also off campus across the country, and delivering and accessing their appropriate application environments. Our other areas that we specialize in, so education reaches into the healthcare environment too. So we have a number of environments where we're empowering the physicians and nurses of tomorrow. We're using the training platforms that are required there to deliver anything from the level of a 3D body image as a result from CAT scan to radiography, to analytics right down to the level of arterial level within with a photorealistic image and representation of the human body. All of this learning, some of it being done on virtual reality, all of this being driven out by NVidia technology. We operate trial environments, so you can access vGPU technology today. We operate a 90-day trial environment. We did expand that during the pandemic, but that's back down to the 128 concurrent user. Simple to log on and register for a trial. Obviously, you would need a virtual GPU to drive that, and that's where obviously our friends at Blue Sky come in. You work with them, and they'll provide the platforms and set up and enable the environments for you. There's a host of resource available on the web. If you go to NVidia.com, you'll see access to videos and webinars, to different references, to white papers, and even application sizing guides. Now, the next slide I'm going to drive to, hopefully it'll come across on here. So if Jonathan, if you can give me a heads up, or otherwise if this video runs. So this is going to be an introduction to the latest collaborative platform called Omniverse. This is where we can allow access to a number of different high-end applications. It could be Maya, it could be DesignWorks, and each of the users can collaborate with each other, and each will see an outstanding a view of everybody else's work. So I'll run this and let's see what happens. So what I'm going to do, if I can just, if I can find the right place in the video, hopefully, I don't know if the audio came across at all there.
No, I'm afraid we didn't get audio, but the video stream wasn't too bad. But the key thing is what we'll be doing is putting resources online. We'll give out some links later in regards to where the original video was online, etc.
So I'll just briefly say, so what you're seeing there is 3 separate windows. So this is a number of different users. So somebody at the Substance Painter is working on that, and a different individual is working on the elements within the view at the top, and then Unreal Engine is driving and tying that all together. So 3 different users with 1 output, and that 1 output is being seen by each of these 3 users. So as a change is made to the wall there, and a recolorization, each of those 3 users see that in real time and in photorealistic output. Now, the links that Jonathan mentioned there, one certainly to look into would be a link from BMW and GTC 2021. If you follow those two titles, this is where BMW are actually using Omniverse to design and configure their factory of the future. They've recreated every nut and bolt right down to the last element within Omniverse, so they can now plan their factory and look at how the workflow runs through that factory. Once they've finalized on the workflow, then they will build the factory. And as they're working through it, they can refine any different methodologies as they go. So, you know, if it's an object, it can be designed. If it moves, it can be automated. You saw the robot arms there. This is where we train the robot arm to do something, and then we iterate many, many thousand times in the virtual space before finally we download that training file into a physical robot, and all the training has been done in the virtual space. So it really does reduce the time. It's a platform that's going to change the way a number of things will be designed and operated in the future, from the media and entertainment industry in the virtual stages. If you've seen The Mandalorian, a lot of that was delivered by the virtual production house within an Omniverse environment. We design our own GPUs on board as we look at airflows and heat across. And obviously, we're a global company, so the fact that we can collaborate as we design means that, you know, we can operate far more effectively. So as it's something to keep an eye out for. It's certainly a design tool of the future. Okay.
Thanks for that, Simon. So essentially, I appreciate not everyone's joining from an education institute, but the key thing that Simon was going through is about realistically how a GPU-enabled VDI, regardless of whether you're just a generic office user right up to high-end designs, there is a product line available to offer that as a VDI service. We've been offering VDIs with GPUs since the original Grid 1.0s, NVidia call it, which was the Grid K1s and K2 cards. Through that evolution of the hardware and the software elements to it, simply with the new Blast Extreme protocol from Horizon, and the Citrix protocols can now be accelerated through the graphics cards. So what we've typically seen is on a 1080p full screen video, we've seen frame rates go from about 9 to 10 frames per second, going up to 30, 35 frames per second. Now, to put that into some standards, your general TV would update at 25 frames per second in the UK. So the frame rates that we are able to deliver for the user on the receiving end, most of the time they're unable to see any difference whatsoever. We've been involved in some radiology departments recently, whereby people are wanting to view CT scans, MRI scans and X-ray scans from home, partly due to the COVID, but also home working is being more embraced within the NHS. Traditionally, hospitals have looked at VDI to proposing that solution previously. However, due to poor performance, they haven't continued down that path originally. However, due to COVID putting more emphasis on that, the VPNs are struggling to keep up with the size of the files in terms of downloading the images to then view them. What we've now managed to do with the NVIDIA hardware in the back end and some nips and tweaks to Horizon, we are now able to deliver a full 4K MRI scan or a CT scan in full 3D, and the users are now able to sit at home and able to use the platform without any latency or lagging for the visual experience. So realistically, you know, the product has come a very, very long way in terms of the grid. And as Simon mentioned earlier, we have the choice of either the VPC, which is your standard user. So whether it might be bit of Photoshop or general web browsing, etc. A lot of these programs now being offloaded to GPU, and even Office applications such as Excel, Outlook, even those applications now Microsoft are using the GPU to render. So what we typically tend to see is with a generic work user, we are seeing substantial decreases in CPU usage for both the actual virtual machine itself, and ultimately the entire server real estate for offering those VDIs. So the key thing that we're trying to raise to people and bring their alerts to is that the GPUs aren't just for people that are doing graphics design or 3D modeling. There is a product to fit the low end and the high end for those graphics utilizations. So Matthew has asked a question. So it's around the Omniverse element, and what he's saying is, how is it practically delivered? So Matthew, as we're running over time, what I'll do with yourself is we'll organise a meeting with NVidia, and we'll go through and discuss the Omniverse and how we can bring that together and ultimately deliver that to you as either an on-premise or a cloud solution. So we can offer the VDI from our cloud platform, or we do deliver on-premise platforms as well, utilising some of the design aspects we do in the cloud. So if that's okay with you, Matthew, that's what we'll do. Yeah. Does anyone have any questions at all? Or any points we just need to recover? No, I think we're okay on that. Right, on that side then, Simon, if you could pass the host over to Jonathan, I'll let Jonathan run through with the Lenovo side and in terms of how they bring those components together.
Yeah, just bear with me.
No problem.
Okay.
Over to you, Jonathan. Jonathan, you're on mute, by the way. Okay, it seems like Jonathan's. Oh, there we go.
Right, here we go. The wonders of technology. As soon as I shared my screen, the other screen disappeared completely. So anyway, good morning, everyone. So my name is John Tyrrell, another Jonathan, but call me John by all means. I work in Lenovo. I'm part of the well, technical architect team is probably the best description. But I support our customer set and also mainly our channel of how we sell through to our customers through our channel partners. Blue Sky being obviously one of those. And so what I wanted to talk to you about over the next sort of 5-10 minutes, don't want to take too much time, just to give you a brief introduction of who we are in terms of our infrastructure solutions group, which is really the area where we can help enable you to harness the power of the the NVIDIA product set you've heard about a minute ago. I just wanted to really focus on we call ourselves the infrastructure solutions group rather than our old name, which was the data center group, mainly because we see, especially over the last few years, data center or data center technology is no longer just in dark machine rooms in 2-meter high racks. It now really spans to try and really get to where the data needs to be computed and harnessed really. And on that picture, hopefully you can see my screen where it's got my introduction title. But on the wall there, you'll see one of our edge servers. And even at this edge environment, this is on a factory wall, but it's really trying to get compute close to where the data is, to where you need to analyze data. In this case, this might be doing some inferencing work on what's happening on the production line in real time. But the important thing is that can contain one of the NVIDIA T4 GPUs in it, even on those edge devices, And we see quite a lot of this now, you know, especially, you know, if we go to the educational example use case that we were talking about, you know, you can take, you know, perhaps 2 or 3 of these, make them into a cluster, put GPUs in them, and have a very powerful environment close to where you need it, without necessarily needing, you know, traditional rack type environments. You know, it can look at, you know, much higher tolerances in terms of temperatures, you know, dust filters, all of these sort of things if you need them. Likewise, you know, we have a whole portfolio, and I'll talk a bit about that now. So just moving on, you know, away from, you know, who we are, and, you know, in terms of a name, what is our branding? You know, this is a quick view of, you know, what traditional data center used to look like. You know, this might be just a small rack, or, like I said, one of our edge servers nowadays. But they all come under this ThinkSystem branding. So ThinkSystem is where we actually look at the actual servers and any of the storage solutions that really drive, you know, we call it the future defined data center, you know, that could span out into your workspace itself. And then Think Agile is our other brand, where we take those ThinkSystem components, we marry them up with some of our key vendors, software vendors, people like Microsoft, or VMware or Nutanix, really looking at software-defined infrastructure, which can form, you know, a very solid basis for, you know, a VDI type cluster. You know, perhaps using vSAN technologies for VMware, yeah, some of the Nutanix Acropolis technologies, or even some of the Microsoft Azure Stack HCI, you know, scenarios. And then we underpin all of this with our XClarity systems management solutions. So whether you buy individual ThinkSystem units, whether you marry them up with different other vendors as a Think Agile solution, you know, we can put bulletproof management, so that, you know, you manage those environments in a very simple, agentless, seamless way. Now, we talked a lot about virtualizing, you know, many desktops, or virtualizing a few very, you know, mission critical desktops. Reliability is always going to be key in this. And we're very proud, you know, for the last 7 years running, we've been at the top ranking in terms of reliability, you know, 5 nines of reliability for our x86 infrastructure, you know, whether they're running, you know, just traditional CPU workloads or GPU workloads in conjunction with that. And you know, looking against some of our competitors, you know, we've got the least amount of unplanned downtime. Yeah, this particular stat is greater than 4 hours, but consistently, you know, we've been shown to be at that number one reliability, which may surprise some of you if you've not looked at us before. But we've been consistent in this area for 7 years running. We put a lot of emphasis around that when we design our systems. And it, you know, if it can be reliable, but if it doesn't perform, you know, that's not really going to help you either. And, you know, and when we're looking at especially GPU environments, they not only need to be reliable from a, you know, power, cooling, thermals, you know, dynamics within the machine, but we need to make sure that all those components, you know, work together in harmony to perform as you'd expect. We're very proud of this stat. We actually are in more than a third of the top 500 supercomputers around the world that run on Lenovo systems. And even if you're not looking at supercomputers, if you're looking at traditional business workloads, you know, VDI being one of those, you know, for perhaps, you know, office workers, right through to graphics design, we do actually hold the number, you know, the highest number of world benchmarks across, you know, industry standard business workload performance. And again, just proving that, you know, what we're saying, you know, is what we do. How do our customers leverage GPUs? In all of the above, really. You know, VDI is one element, but we're also seeing a lot of interest, you know, not only in HPC at the top there, we've already talked a bit about that, how we're, you know, more than a third of top 500 run on Lenovo, but also in a lot of mixed AI workloads, you know, a lot of deep learning workloads, and also at the edge. You know, I was talking about our edge computer, where we can, you know, harness the power of GPUs in that as well, in a non-traditional, you know, non-rack environment. This is just some examples of recent innovations. We've just released, you know, Ice Lake systems with the new Intel announcements, and similarly some Milan systems on the AMD side of things. This is one of our Ice Lake systems. We're actually able to harness the power of some of NVIDIA's, the A100 chip in this, or GPU in this case, which generally, does, it is at the top end of the range. It does generate more heat than some of the lower end ones, but we can harness that with some of our unique, we call it Neptune as a branding, but our liquid to air, hybrid cooling technology. And the good thing about that is that, with some of these clever techniques, we can still pack the systems, densely with lots of other, design points. So, not only are we getting GPUs in there, very high end CPUs, we can also add in, additional PCIe 4 adapters in there. And also, as you'd expect, the drives, the storage to drive those workloads. And there's another example here, where we're putting 8 of the PCIe variant of the A100. And again, we make sure we have balanced systems here, so we can marry that up with the latest NVMe drives to drive those workloads. This is the eye chart. It's intentionally an eye chart. It is our full range as it stands at the moment in terms of model numbers. But what I wanted to get across here, that even if you don't look at that SR670 box at the top of that rack list there, those are the pictures I was showing you a minute ago. If you look at any of, the rest of the range, we do enable NVIDIA GPUs right across the range. We believe very firmly in one size does not fit all. So we can right size the right machine for your workload with the right GPU, to make sure we optimize what we're trying to do for your particular use cases. And that's the key point here. Making sure you have balanced systems for the use case you're using it for. Whether that's right on the left-hand side with that edge box we talked around, the SE350, or right up to the multi-processor SR860 V2 on the right-hand side there. We've talked a bit about edge clarity. No matter which one of those systems we're looking at, we can manage them all with the edge clarity engine. And the good thing is, within that engine, you can look at not only, alerts and things like that, but also all the thermals within the box, and get predictive failure alerts on those as well. And it's simple, it's automated, it's extensible, so we can provide a dashboard with a heat map, red, amber, green, of what's happening in your estate, or we can embed dashboards within your, what you're already using as your management tools, whether you're using VMware, Microsoft, Red Hat, with Ansible, Splunk. We can put integrations into there, so you don't have to come out of those tools to manage our systems. And the good thing is they're easy to provision. Whichever route you go here, it's all done on an agentless out-of-band method. So, you're not forever managing agents for the rest of your life. Everything's very simple and easy to deploy. Just looking a bit more about, what we support, we do have, down the range of our different systems, we have various reference architectures and, sometimes pre-canned solutions, if you like, where we've done a lot of the hard grunt work, working with the different vendors, in this case Citrix, to make sure we have right sized building blocks, so you don't have to reinvent the wheel every time when you're looking for a solution. Come to us, talk to us. We can point you to proven solutions that have already been written up, sized for you, in collaboration with those different vendors on the left-hand side there. And we do a similar thing with VMware as well. And then we do have some other ones. There's quite a lot of other ones. Haven't really got time to go through them here, but with the likes of Red Hat, if you're going to use more of a Linux-based solution as well. We've already talked a lot about this, but the good thing is, if you're buying a bill of materials from Lenovo, the NVIDIA vGPU software can be a part number within that bill of materials. We work very closely with NVIDIA on this, and we can, I'm not going to go through this again with you. We went through this with Simon, but the good thing is we can include it in our bill of materials, just as another line item. And the good thing is, because of that, we can offer support around it as well. This is really my closing slide. Well, what I wanted to get across from here is that, we are the Infrastructure Solutions Group. We are part of a bigger Lenovo. So we, if you are looking at virtual desktops or virtualizing desktops, whether that be, office workers right through to, power, CAD, CAM, design work, we can marry it up with the right, thin clients if you need it, or in some cases, with VR or augmented reality headsets. We have quite a broad portfolio across the whole Lenovo range, outside of Infrastructure Solutions Group, in what we call our Intelligent Devices Group. And even back to things like the mobile technology, we own Motorola as a brand. One of our latest phones, you can actually run a full Android desktop on it and almost use it as effectively use it as a thin client in your pocket to marry back up with a data center, virtual desktop environment. So lots of things to think about there. We are one Lenovo. We act as one Lenovo, whether you're looking at our client devices, any of the other pieces that we talked around, or right through to our Infrastructure Solutions Group. So I'll leave it there for the moment. I don't know if anyone's got any questions for me. I can answer them now. If not, we can provide you these slides and various links to
I've got one question, which is, how are the VR headsets? So like with the VR headset, do you have a mouse input or a VR controller as such?
We can have a bit of both, really. We've got different solutions depending on what you want to do. So one of the recent ones we implemented was actually a VR headset. You could marry up with your desktop environment, or even your phone, whether that's an Android desktop, and it would actually give you a heads up view of 3 different screens, as if you were sitting at your desk with 3 HD screens in front of you. Okay. Or we can go through to the full immersive environment, with VR controllers and things like that. So
no problem. So that was Matthew that asked that. So what we'll do is get a product list in regards to the VR.
Yeah.
I know roughly where he's looking at going on that one. So what we can do is send something specific to yourself, Matthew, around the headsets, etc., on how to use that, and the product that actually would deliver what you're looking for. Magic. So realistically, just to cover that off, Lenovo we've been using for 6 years now, and we have Lenovo throughout our server real estate in the data center. So all our VDI hosts are on Lenovo, and we use the NVIDIA graphics cards in the back as a default offering. So within what we've spoken about today, as I've mentioned earlier on the NVIDIA part, we can either deliver an on-premise solution if that's what you're looking for. However, what we are seeing is a focus towards cloud first. So essentially we can host that service for you, either on our shared platform or a specific platform to meet the needs. We are not this one box fits all organization. What we actually look to do is what you're trying to achieve, what your workloads are, and ultimately how do you need that user experience to be. Then utilizing from the Lenovo side and the NVIDIA side, we have essentially managed and migrate those two different parts together, and then wrap our services around that and offer it as a full managed service. So then that way everyone can get on with what it is that you need to do, rather than being focused on the IT element and dealing with failures or dealing with working from home and not having correct access into your work environment. So then that way it's dropping the borders away from your local IT. And that's what we typically are tending to see. So I apologise for the overrun on this. Hopefully the additional information has been of benefit. if nobody's got any additional questions, we can call a close to there, and thank you very much for joining. So I'll just double check first if we've got any questions. No, we don't. Magic. Well, thank you ever so much, everyone, and I hope you have a good rest of the day. And thank you to Simon and Jonathan for joining to present, and hopefully we'll speak to you soon.
Thank you, everyone.
Thanks ever so much. Bye bye.